Hello, everyone, and welcome back to the Altium OnTrack podcast. I am Zach Peterson, your host, and today I'll be talking with Yuriy Shlepnev, founder and president of Simberian. For those of you who have been watching the podcast for a while, you probably remember Yuriy as one of our prior guests, and I'm very happy to have him back here today to talk to us about some of the newest developments in Simbeor. Yuriy, thank you so much for joining us.
Thank you, Zakaria.
Yes, so I follow you on LinkedIn, of course. I see you posting, updates to Simbeor, and frankly, it's one of my favorite simulation tools. And so I highly encourage some other folks to go out and follow you and see some of your updates and try out Simbeor. But you've been posting some pretty interesting stuff about AI and agentic AI in signal integrity. So I'm hoping we can just kind of jump in and get your thoughts on the use of AI in electronics design and simulation, and specifically in signal integrity.
So, Zakaria, whatever I say is going to be obsolete in a couple of months. So this is so dynamic area. So when we started working on AI back in maybe June, July, and before this, I didn't have exposure at all to all this stuff. Only just use of chat applications like ChatGPT or Copilot or Gemini. Use of for coding, obviously, but then all of a sudden it happened. So and it happened. Our customers started building agentic systems on the basis of Simbeor, and I noticed it. So the first live system that was demonstrated to me was built by Alex Manukovsky team at Intel, and you probably saw those postings as well. He basically influenced me a lot on this. So they demonstrated a completely functional system level agentic workflow based on Simbeor and some other tools, and it was just unbelievable to me. So that LLM, which is software, can decide for you what to do, next step, and so on. So I don't know. That's how we get started. And fast forward, that's where we are with the release of Simbeor 2025-01, with I believe first SI agent or SI agentic system. It's actually has multiple agents inside in signal integrity software. So generalization of this is probably impossible. It's just kind of right now what's happening. It's difficult to follow in different area. But I'm not aware that of EDA software where LLM is actually working inside, not as a help system, not as a kind of assistant type, but actually running the software to like real engineer.
Sure.
So basically engineers work they work on a prompt, right? So prompt from management, prompt they generate themselves, and then they start working like what software I'm gonna use, what I'm gonna do to accomplish that task, and basically make sure that something is compliant with some standards. So that's naturally it falls into the domain of LLM capabilities.
Well, what's interesting about this is, LLMs are kind of the game changer here, because if you look in the recent past, right, the use of machine learning and AI to do some things in signal integrity, I think is not new. In fact, you mentioned Alex Mikovsky, I think
Yeah.
his name is, from Intel. I recall a design paper or a design con paper
Mm-hmm.
where he was looking at link optimization using machine learning. and it was for
Exactly.
112 gigabit per second serial links. And that was back in, I think, 2019 or 2017. It's a little bit
90,
older.
19, yes, 19.
Yeah, yeah. So you know the paper I'm talking about, and I've cited it quite a few times myself.
Yeah, it was range analysis. Basically, idea was to establish the boundaries, where the system will not fail. And we use COM metrics. And by the way, version 2025 of Simbeor also now support automatic computation of COM, which is really easy to use now. But COM was used as a one final metric for machine learning system to establish this space where everything just always works, no matter what kind of there might be multiple deviation just in a particular component, but overall system may work. So that's what basically happened when you do not pay much attention to signal integrity, and all of a sudden everything works. So you feed this space. So even if your V are not designed properly and many things are not done well, but yeah, that was. But unfortunately, the whole approach happened to be really complicated, so complex, and even for a team, Alex team, it was too much work. And now they have different approach, and Alex will talk about this new approach at the oncoming Design Con. So it's not based on machine learning, but basically now they use AI helpers to make sure that the system works.
So in some of those prior approaches with machine learning or AI, it was really like link optimization, where you basically set up your topology, right? There's, chip number one, chip number two. Maybe you have a coupling capacitor between them, and you have to figure out which layer does it route on, how are the vias set up, those types of issues. And with those approaches, I think it's the machine learning model basically learning the convergence path to the optimal design. Is that the correct way to think of it? And
Yeah, some people do
LLMs are
it in
kind of
this
doing.
way. Some
Okay.
people do it in this way, but no, that was different approach. The approach was just essentially establish the boundaries for each particular parameter in a system that may change. For instance, stackup structure. So you have 4 different manufacturers. There is a differences in stackup structure and differences in manufacturing tolerances. So you put it in the picture. Then this is a given. You cannot do much about it. Then you have VIA design and how good should be VIA. So it's not, you don't need to redesign it every time for every manufacturer. So what if we design an average VIA? Will it work or not? And then if you put all those things together, there are kind of most important contributing factors that you have to watch out. So if everything like within this space, it's not optimization even. It's just kind of big sweeps and use of machine learning techniques to establish the boundaries. So that's optimization is a different path where people use machine learning and reinforced learning and build models and so on. But that's such approach may fail in mass manufacturing, and we showed it at the last design con. How on a VIA design, there was a paper on waveguiding approach to VIA design, and some VIAs failed due to the fact that they were over-optimized, small antipaths, for instance, and then 2 mil misregistration just killed those VIAs, and they were kind of way off the ranges they expect for a system to remain functional. So that's where we started working on new approach to VIA design, and so it's still work in progress. As a matter of fact, so just reduce VIA sensitivity to manufacturing kind of deviations, and that also changes the whole perspective of design approach. So you don't, in reality, things may become really bad if you do not account for all those manufacturing deviations.
So what I'm hearing from the prior approach before we bring in LLMs is rather than try to converge to the perfect design where the manufacturing tolerances may not actually produce the perfect design and cause your design to fail, you just get to a good enough design with a range of possible solutions, and you can basically say to the designer, okay, as long as your etch factor is within this range and your spacing is within this range and the anti-pad is within this range, those kinds of things, that then it will be good enough to pass channel compliance.
Exactly. And that's why we are with all those ever increasing data rates, because of in our earlier approach of predictable interconnect design, we was striving to have the analysis to measurement correlation at the end. And this is possible up to like 40, 50 gigahertz, and then things become probabilistic actually. So you cannot really have perfect correlation just because of manufacturing, and even the best manufacturing gives you all those deviations. So you have to stay within some boundaries in there, and then it may work.
So this is where I think over time, we've gotten to the new way to do AI, which is predominantly with LLMs and probably SLMs as well in certain applications. So now what I'm wondering is how are LLMs fitting into AI applications in signal integrity? Is it just doing the same thing that was done before with trying to converge to a good enough design space?
No. There are people in this area who use LLM for optimization, like Chris Chen, another influencer. He influenced me with his work in area of machine learning and AI application. So, and recently at the PIPS, they showed paper where they use LLM for optimization. But my opinion is LLM is not good at it. It's language model. And we started with simple tasks like, okay, here is strip line, make it 50 ohm. So it does 10 iteration and makes it 51 ohm, and then you ask it, well, can you just make it closer to 50, and does another 10 iteration and so on. It's not designed for this, and it's not. It's like iteration. In some cases, it does do it properly, like a human. Like if I give you this task, you use division by 2 and quickly converge. But LLMs in pure LLMs, they are not equipped with optimization tools or with, they know algorithms, but then you have to say, well, use this algorithm. So my
Or
opinion
you have
is
to like let it code an optimization scheme and hope it codes it correctly.
Right. And hope that it follows this code. So like implement step by step optimization algorithm. So my opinion is very simple on this. You have to create tools, deterministic tools, like search engine, like optimization engine, like analysis engine, signal integrity analysis. That's what we are building. Our AI for SI project, which we started somewhere in July. There is a roadmap that basically leads to completely autonomous agents that use signal integrity software, but they use signal integrity software in deterministic way. So whatever can be done by a solver or a software should be done by a software. LLM just orchestrate things, create plan. If you give it a prompt, and I'll show it today, it immediately goes into this planning mode, reasoning, and then it comes up with a plan, and then follows this plan. So just one step at a time. If you need to analyze results from a previous step, or just one step at a time and do the whole thing. So it can do it well, and that's what we essentially creating things that software user technically. So I have a lot of experience teaching our customers how to use our software. And our company is already almost 20 years. So all over the years, I observe behavior of customers, and then we refine software. Then we teach them again, we refine the software. And so over the years, we achieved very kind of almost automatic mode. And in Simbeor for some tasks like post layout. Now with LLM, finally, we are reaching automatic mode in pre-layout, which is the most time-consuming part of signal integrity work, like stackup planning. And I'll show you today how enormously helpful this language models in stackup planning, comparison, and translation from different formats, because of that's what it is. It's a language model. It's good with translating one format into another, or one language into another. So and my goal, or our goal, well, in our team, I am context creator. Frankly,
Right.
Other people just helping me to link my knowledge with the tools and with LLM. So it's a kind of two-part project. Tools on this side, LLM on this side, and in the middle is context. And context is basically training material shortened to just most important part to backbone and just enough for LLM to understand what it is, what context, what has to be done, goal, and what tools it can use. So, and optimization is obviously have to be done with optimization tool. So sometimes AI word right now in EDA, it's thrown everywhere. You can see podcasts where people talk about AI, but in reality, it's about mostly reinforced learning, for instance, which is a part of AI, but it's not relevant to LLMs. Well, LLMs, they created with reinforced learning, but reinforced learning is just creating neural networks for solving some problems. And I was always objected to this approach in analysis. So there are some kind of people that few universities probably that use this technique to create digital twins and all this stuff. And with existence of fast tools, fast semi-automatic tools, you don't need really create digital twins. This is already digital twin, the solver.
Yeah.
Exactly. That's not a task for a brain. You see,
Right.
that's why we created those solvers. But task for a brain is just plan, orchestrate, call the tool. So instead of punching the buttons, call the APIs and send all those parameters necessary and figure out parameters essentially. So it's a part of signal integrity job.
Now, if I could jump in, this is interesting because when LLMs first came out and became very popular and people were trying to use it in PCB design, the discussion around how LLMs would be used would be that you would take like your prior working designs and use those as the training data, and then you're supposed to like train a specialized LLM on your proprietary data, and then it would generate new designs based on a prompt. And I mean, maybe that works in PCB layout for placement, but what you're describing is totally different, right? This is not, taking a bunch of designs that worked or didn't work and training on that. It's actually agentic in terms of now this thing is going to go out and use your software for you based on the plan and orchestration that you set out.
Exactly. So with the training approach, with the training, and I know from some podcasts that big companies are working on kind of they cannot use data from all customers, so they say, well, we'll create a kind of database that exactly for your company. But take a look at the amount of data they use to achieve this kind of intelligence in LLM. Nobody knows how much data you have to use. Basically, and what is a good design. So you take a database. We have a database, for instance, like close to 300 different designs from our customers, and so for debugging purpose, for just make sure for regression tests and so on, that we do not break with every new iteration, we do not break it. But 300, are they good? Most of them not. I mean, because they have problems of different kind, and that's why they use the signal integrity tools first of all to optimize what is optimized version is going to look like. And in a company, you get all the range of designs from 1 gigabit per second to the most recent one. And the most recent one, you cannot use it as a training material. So it's a dead end. Even in layout, if layout is more kind of brain-like activity, because of people are capable of doing it, right? So you very well trained people can create layout much better. But how much time will it take? Like if you have 60 layer design and so on, I don't know. Simple stuff, yes, people do even better than best routers, auto routers. But what about more complicated stuff? And that's in analysis, it's not like this. Nobody can, I can show you a picture or description of cross section. You'll not tell me impedance of this. Like even myself, I can, a few configurations I recognize and say, tell you the impedance. But if it somewhere else, so I won't be able. And so my brain cannot be trained to predict it. That's why we use equations or solvers, field solvers.
Right. No, what I'm hearing with the problem with that, especially with SI, is that there's too many parameters, there's too much categorization that goes on, and then you mentioned, if you only have designs that go up to, let's say, 28 gigabits per second, there's no guarantee that it gives you anything of any level of sufficient accuracy at 56 or 112, right?
Exactly.
Because it wasn't trained on that data.
No. That's basically what we try to do in those machine learning projects with Alex to kind of create some generalized models to be able to predict will it work or not just recreate or so. Analysis is here to stay, but probably in completely different form. Not with a GUI or with it's too much work, and to do even a simple signal integrity design. And fortunately, LLMs are capable doing this for us, and that's basically it was discovery to me. And we started from we started in July probably, just creating simple questionnaires like 100 advanced signal integrity questions, and generated rugged few sources and and most of the LLMs came out as with very high score, and I've got it somewhere on my computer. But like close to 90 questions correctly answered. So it basically it qualifies it qualifies it for the signal integrity job, basically. Not exactly, obviously. There are a lot of activities in signal integrity that outside of this kind of knowledge domain,
Sure.
or where you just answer questions. And but that, and then another thing is they were very good at some of the models, not all, in using tools. So all this stuff appeared quite recently. I don't know exactly the timeline, but this is within the year. Within the year. So even those interfaces that we used in the beginning for tool calling, they disappeared. Gemini changed interface. Like it was right here, it was calling the tools, and now it's not calling the tools. And we changed the interface, and now it's better.
Yeah.
And obviously, yes, but we need to catch up and so on. So things are changing. Whatever we're doing now, maybe we're just wasting the time, and people who will start doing it in half year or in a year, they'll have much easier life.
Well, I think now is a good time to probably jump
Yeah,
into a demo to see what you've created. I think this is going to be
yeah,
pretty cool.
okay. So now in Simbeor, we've got this helper, which is Simbeor commander, right here. This guy. So right now it's equipped with Quen Plus. And the first question, the model is just plug in. So whatever, if you have local models, it works with local models. If you have don't have local models, it works pretty much with any capable model through Open Router or directly. With the Quen, we work directly with I believe with Gemini, with OpenAI, we work directly, but with other models, you can walk through. And the first question, what can you do? Again, even asking this question every time, I get slightly different answers. Sometimes very brief, like this. Sometimes more elaborate, like on a couple of pages. And it depends on a particular model. It depends on the time of the day. I don't know. On weather, maybe. So right here, it's that's what it can do right now. It's a project in the beginning. If you know Simbeor, it automates some tasks that used to be done with wizards. So you launch the wizard, you follow it, you change the parameters. With this, you can this thing can use those wizards for you. So far, the capabilities are limited to creating solution, creating project, importing stackups from some unusual formats, and I'll demonstrate it today. and investigation transmission lines. So, for instance, I can start with a simple investigation for like 112 gigabit per second PAM4. I need 50 ohm strip line, and with core with like 5 mil core and 6 mil or 4 mil. I'm just improvising.
Yeah.
Prepreg. And for core, I will use decay, for instance. You can use words, you can use anything. Decay like 3.2, prepreg decay 3.5, loss tangent 0.001. What else? It basically has everything that Simbeor is capable, and roughness.
I have a question here. You're specifying specific DK values and thicknesses, but let's say I instead I said I want to use 3 mil Megtron 7, right?
Oh yeah, 3 mil Megtron 7 with okay 3 mil Megtron. Let's just do this, and then we'll do the Megtron 7. It knows everything about Megtron 7.
Okay.
And just jumping ahead. So you can. So this is our stackup. How many clicks it saves? It's already a lot. So it created prepreg, it created core, and it put it in the stackup. So now I need. I need. And it give me width 4.39 mil. This is the answer. I don't have anything to do. At this moment, I can create a model for this trace and plot attenuation. Just attenuation. So for 112 gigabit per second, you see, it duplicated it and forgot to check that already there is such project, and that's a kind of minor hallucination we're observing, but it did the task. So no matter what it is, here
I guess you just needed to say take the existing model and add the graph, right?
Exactly.
Simple prompting fixes it.
Exactly. Hallucination is coming from two parts. It's either insufficient information in prompting, but I can assure you that this thing just needed to take a look at the solution. So it has a vision of the solution. Solution is a canvas for this kind of Simbeor commander. So, and in this case, it just probably decided to save some time and simply recreate it. And so now let's just create stackup from Megtron 7. Need stackup. With core and prepreg for mil Megtron 7 and 85 ohm trace geometry.
Now, when you say 85 ohm, is it going to assume that it's a differential pair? Because that would be a typical value that you would see in the differential pair range.
Exactly, Zachary, you exactly right. So I miss the word differential, and let's see what it does. Strip line 85 ohm is a differential, and we can take a look. It is single-ended.
Okay.
Now we okay. It actually builded attenuation plot 85 ohm, and it does everything. Let's just take a Mectron 7. It used 3.7, 0.01. Is it correct?
I think for Megtron 7, it gets down to 3.37, I believe. So maybe that's like Megtron 6.
What is decay and LT of Mectron 7? So let's see, is it in its knowledge base or not?
Ah, okay.
3.7, it just, I don't know. Where did you get it? Would be the next. Actually, we collected all this data, and we're going to supplement everything you do with the typical materials, the knowledge to kind of to our agent. So far, it gets it from its kind of its brain. So it's static. It's from its static brain.
Yeah, yeah.
But I actually needed 85 ohm differential for the Mectron stackup. It should identify that basically we are talking about this project here, and it should build 85 ohm differential. But that's a kind of
There it is.
yeah, it is 85 ohm differential, and this one is let's just make sure that it is T-line differential. Yeah,
Okay.
85 ohm differential, and it gives all the parameters. And
So,
actually,
so
if you notice, it converted RZ from for surface roughness into parameters of Yuriy Bracken model in Simbeor. So it knows a lot. I mean, like about the modeling, about type of the model, dielectric conductor roughness modeling, knows all this.
So when it spits out the 85 ohm differential pair, right? The native Simbeor tool is being used to calculate what the LLM tells it to. So like when you see the 85 ohm in the result here on the left panel, it's actually calculated with the Simbeor tool. It's not just a copy paste from whatever the LLM said.
No, it's created by Simbeor tool, exactly.
Right.
So it uses the tool call, and taking this prompt, it looks at one of like about 2 dozen now different tools. Probably three agents working here. Simbeor commander is orchestrator, and transmission line agent. It uses stackup building agent, stackup import. I will show you the next. And so on. And transmission line agent equipped with different tools to synthesize and to analyze, to build models, and to plot them. So
now I have an interesting question here, right? Because sometimes, or one of the criticisms with LLMs is that they allow people to kind of create an echo chamber, and this is outside of engineering. But if you give it a prompt that requires a ridiculous and non-factual answer, it can still pretend like the answer is factual just because it wants to satisfy the user. So are there situations where you could request that it create, for example, like a 50 ohm line on like Rogers 3003, but then you give it a constraint that will not satisfy the 50 ohm requirement, right? Like let's say, for example, I want a 50 ohm transmission line on 5 mil Rogers 3003, but it has to be at least 20 mils, right? Well,
50
obviously,
ohm line on Rogers
yeah, 3003.
R3003,
Yeah.
right? What else?
I was thinking if you put a constraint on it, like that's at least 20 mils, right? Because we know that line is not going to be, 20 mils wide for a microstrip.
And it should
If it's on 50 mil, if it's on 5 mil Rogers.
Wider than 20 mil.
Yeah.
We can use actually millimeters, and it will do it in millimeters. So another nice thing, it's kind of unit blind. So it converts everything back and forth into Simbeor units, or use the units you specify. This is part of the language convenience. 20 mil. Okay. Let's just see what it does. Now it's microstrip line. It created microstrip Rogers 303. You see these parameters. And okay. Successfully designed. Meet your criteria. Meet my criteria. Okay. Dielectric. Oh, it created 20 mil dielectric to satisfy.
Right. Well, that's the size that would be required to create such a large transmission line. So I guess in this case, you kind of under constrained it, and it just gave you something that, I mean, technically it did to satisfy the requirement, right?
The substrate must be 5 mil.
Yeah.
Do it again. Okay. Now it should basically create another project. Yeah, it created another project. And now it's 5 mil. Now it's Rogers. And now it will probably it's thinking hard and does not meet your requirements of being wider than 20 mil. Okay.
I see. Okay. So it will tell you that, you can't actually do this thing that you requested, but here's an example on the 5 mil Rogers.
Yes, exactly. And it's in context. This is first, there is no kind of, the temperature is set to 0. So it's not in the mode of fantasizing or stuff like this. And another part is context. Remember I mentioned that this technology comes with this, or maybe I did mention, from 3 parts. LLM, obviously, brain, then context and tools. So context and tools, they constrain all the things. So just because of, if you like our first version, Qwen, it was just extrapolating data, and then sometimes it was even using the formulas inside Qwen to simulate it, and explaining it. It's just faster, and it's easier to do it like this. No, that's not what we want. We want actually signal integrity tool and be helper in this.
What's interesting about this, because you just called it a helper, is that it actually offers some approaches you can take that is going to help you satisfy the constraint, right? Because right here you say, recalculate using thicker core or embedded microstrip or an optimization for manufacturing.
Exactly. So, that's one mode. There is another mode I'll show you right now after I demonstrated it to one of our customers, or not even one actually. And they immediately say, well, we need it. And let me just show close solution. Oh, by the way, we were doing everything for 112 PAM4, and you see it was simulating it properly up to 76 gigahertz. And if we continue the analysis here, just regular pre-layout with compliance analyzer, we'll see everything adjusted to like 112 PAM4.
Okay.
Yeah, that's one of the things probably kind of from the beginning that maybe missed. Okay, close solution. And I'll clear the, save it. Clear the brain a little bit. And now I'll show you one capability that basically put it really kind of in, make it really useful in hands of signal integrity engineers. For instance, think about how many tables like this or similar you saw and you needed to put the stack up information in a simulation tool. I have right here a few dozens of examples, like very complicated ones, like this one in Excel.
Yeah.
This
And
is
you have them in multiple file formats, right? You have an Excel one,
multiple
but I also see some PDFs.
PDFs. And this is a PDF right here.
Yeah.
So what if you want to basically take a PDF, this is CMP 28, and compare it with same stackup, but with entered in Simbeor with identified the models for materials and adjusted, and we will see how they differ. So I open a couple of files and import two stackups and compare. I should start with for 28 gigabit per second. This is CMP28 from Wild River Technology, very well documented on our website. Version of it is available from Wild River. Import to stackup and compare stackup structure and material models. Okay. We basically train it to import stackups from either PDF or Excel formats. Those are two most commonly used one. So JSON, it came very quickly. So it's a simple 8-layer stackup. This board was used around 2012, 2015. We use it for analysis to measurement validation with in partnership with Wild River. It was one of the first platforms that allows us to correlate data, correlate our models with reality. And there were other projects, and I'll show you some more. So now it's imported the same thing from PDF. And you can see it preserves the materials. In PDF, all materials are identical. It even accounted for soda mask. It accounted for plating on top. And now, yeah, we have kind of resume what is different and what is similar. So if you start reading, so yeah, it's this time it came with quite extensive report on this. So it's technically a report of why stackups are different. And one of the customers, they sent me two stackups, and that was recent kind of application of Simbeor Commander. They say, well, two engineers entered the same stackup into Simbeor, and they have different answer for impedance or width of traces. Find the difference. What is the difference in the stackup? And it happened to be the difference was in conductor roughness. One engineer specified conductor roughness for materials like modified Hammerstadt or Hurray-Bracken. Another engineer didn't specify roughness. And they didn't expect that roughness make difference in impedance and so on. So this is one way to deal with this now with large language models and importing it into Simbeor, and we can proceed with other tasks. For instance, now we can ask it, well, need 85 ohm differential for each layer in both stackups.
Now, one thing I noticed here, because you're starting to do line generation, right? The stack ups apparently already had specified signal in plane. Is that correct?
Yes, and I can show you how to. Simbeor actually understands, or Simbeor commander, I would say. If I ask it to do, and I can demonstrate it to do in plane, so it may ask me what the reference, or may assume that the reference are the up and one layer up and down. So it actually sees a stack up, and in plane it's going to be coplanar, or I can create coplanar and signal. So all types of, let me just launch this build model and plot attenuation on the same graph. This is a kind of automation. You can actually put all those prompts in a file and load this file, and Simbeor basically commander will like a script, but only in human language. It will start following those. We use it for testing. We have regression tests, like dozens and dozens of questions, and then use LLM also to check the result. So one LLM is doing the job, another LLM checking if it correct or not. And there is a reference result as well. So right now it goes and builds those models, and
yeah, I see your screen is flashing, so it's clearly updating in the background as we're talking.
It's holding the solution, updating, and now it started building the models. You can see models start coming out. It started from initial PDF. You can see 85 ohms transmission line here, and it started building for some reason with even with the image. So it's optional, but you can see all those differential lines coming out. So it supports everything that you can create in Simbeor. So all types of coplanar, you can move the reference up and down, or use skip layers, and all this terminology. You can directly use it and instruct it how to build the cross sections, and trapezoidality, all models for conductor roughness. From dielectric, it uses only wideband debye now. So now we see all these differential losses for all layers, strip line, and we've got the models here, and we've got stackup comparison, and let's just see. It even compared it. You see CMP28 initial, CMP28 JSON.
Yeah.
Right here, it acted proactively. So I didn't ask it to compare, but because of we compared before, and this is maybe advantage, maybe disadvantage. Sometimes it's just a little bit too proactive. But different models behave in different way. If you take a Gemini, for instance, 2.5 flash, it's very brief. It's never proactive, and you cannot really. So the context is a kind of in the middle. So if he put too much constraint as for Qwen, then Gemini becomes completely kind of unresponsive. You need to. It will start asking, "Do you really need to do this?" Something like that. And
Right.
but right here the goal is completely automated agentic system, and right now this is kind of helper for engineers, but in reality we build it for other agents. So having kind of in mind that this thing is going to be used by the other agents through agent to agent or A to A interface. Right now we kind of experimenting with this. So, and those our customers who already have agentic workflow, they will be able to use this to plug it into the agentic workflow for pre-layout design. So the pre-layout is, I mentioned, the most time consuming, and we basically on our roadmap and on our very kind of short roadmap is to enable to implement agent for all types of operations that you typically do in Simbeor. Use of vAnalyzer, analysis and optimization of vehicles, analysis of links with crosstalk, and that pre-layout. Post layout is a little easier. We actually created prototype, but it's not here because of the we need to close the complete loop for post layout. So far, it just can run the analysis in compliance analyzer, but then getting result back and analysis of the result require additional step of kind of translating all graphical result into language.
Sure.
Because of its language model. Yeah. And so to make it understand and create summaries and recommendations at this moment. So this is the first public demonstration, I would say, of Simbeor Commander.
Very cool. Very cool. Well, we're getting up here on time. And I want to thank you so much for going through this. This is so cool to see this, and
exactly.
I'm hoping it kind of expands these capabilities to folks who may not be signal integrity experts, and gives them a way to kind of at least learn more and possibly improve their designs.
Exactly. Learning with this is just unbelievably simple. I mean, if you learn with the tools in hands, and that completely changes the landscape of learning. And yeah, I agree.
So I hope that everyone that's listening will get in contact with you through LinkedIn, or will head over to Simberian.com and will get in contact with the company and hopefully learn about this new product. Yuriy, I want to thank you so much.
All this is available.
Yeah.
So you can download it, plug your LLM, and start. Give it a try, Zakaria.
Awesome.
It's cool.
Awesome. I'm gonna hopefully I can do that myself soon. I'm pretty busy, but I'm eager to try it.
Yeah, so as soon as you need stackup planning tasks, remember that's some practical tasks, and this is
absolutely. Well, Yuriy, thank you so much for being here again. It's always so cool to see these demos when you come on the podcast, and when I saw you posting about this, I was really excited. So definitely, thank you so much for coming here today.
Thank you, Zakaria.
To everyone that's out there listening and watching, we've been talking with Yuriy Shlepnev, founder and president of Simberian. If you're watching on YouTube, make sure to hit the like button, hit the subscribe button. You'll be able to keep up with all of our podcast episodes and tutorials as they come out. And of course, check out the links in the description to learn more about this very cool piece of software that we've been watching in this demo. And last but not least, don't stop learning, stay on track, and we'll see you next time. Thanks, everybody.